Chapter 2, Design Tools, Part 2 of 2. Sketching. Being able to sketch well is critical because of the fleeting nature of ideas. Sketching is a form of visual communication that is used to quickly record and convey ideas before they are lost. Pictorial sketching. Pictorial sketches show three mutually perpendicular faces on a prismatic object and are often drawn in isometric, oblique, or perspective format. Here's isometric, where you can see we have a flat line here, and then we have three lines. One is perpendicular to the flat line that we had, and then the other two are 30 degrees from the flat line, so it makes something like this. Oblique, instead of being 30 degrees, it's 45 degrees. And then perspective. Adding notes to the sketch makes it easier for others to understand aspects of the idea that may not be obvious by the drawing alone. Place dimensions on the sketch helps the viewer establish a sense of scale. Multiview sketch. A multiview sketch is a type of drawing that portrays an object as a series of two or more dimensional views arranged in a specific pattern. Dimensions are usually added to a multiview drawing to communicate geometric information about objects' overall height, width, and depth, as well as the size and location of holes. The most common views given in a multiview sketch are the top, front, and side views. Here we have an example. So the top, right there, the front, looks like that, and then the side. Modeling ideas, advantages, and applications of computer-aided drafting. CAD systems are used in just about every industry, including aerospace, architecture, construction, consumer products, electronics, energy, the medical field, plastics, packaging, and transportation. To win business, companies must provide superior designs more efficiently and at a lower cost. CAD files can be instantly emailed to other engineers and manufacturers around the world. CAD systems have the ability to store models of off-the-shelf parts that are frequently used in engineering designs. CAD models resemble the final project to a degree of geometric precision that is beyond that of a physical prototype. CAD model images are used in the development of instructional use materials. Finite element analysis. CAD systems will calculate the object's surface area, volume, and weight, the center of gravity, and other physical characteristics. FEA is a computer-based design analysis tool that allows the user to apply virtual forces and pressures to a 3D CAD model in order to determine deflections, stress concentrations, and other effects. This type of virtual testing ultimately saves time and money. Computer-aided manufacturing, or CAM. CAM software is used to create machine tool control programs that take the form of G&M code. G&M code programs are used to autonomously operate computer numerical control machines. Rapid prototyping. All RP processes begin with a 3D CAD model, which is sliced into a series of ultra-thin layers. The geometric information for each layer is then sent to a machine where the object is built one layer at a time. RP technologies offer the following advantages. Rapid prototyping technologies are able to produce complex models more quickly and easily than traditional manufacturing methods. RP models can be made from a wide selection of polymers, ceramics, and metals, and some rapid prototyping technologies offer cost-effective alternatives for low-volume production of finished products. Some different types of RP methods: stereolithography, fused deposition modeling, selective laser sintering, and powder binder printing. Stereolithography. SLA process builds a solid plastic model by using an ultraviolet laser to harden a photosensitive liquid polymer one layer at a time. SLA polymer components can be made to especially high dimensional accuracy and detail. Fused deposition modeling. The FDM processes involves extruding a plastic or wax material through a nozzle that traces the cross-section geometry of a part layer by layer. FDM parts can be made from a variety of plastics and specialized waxes. Selective laser sintering. SLS uses a moving laser beam to trace the shape of each layer onto a powdered polymer material. A similar process called direct metal laser sintering uses powdered metal as the build material. Powder binder printing. The powder is made from either starch or plaster. Parts made by using the powder binder printing process are often coated with a sealant to improve their strength and surface finish. Analysis procedure. Engineers utilize a systematic analysis procedure that can be broken down into a series of steps. State the problem, create a diagram, make assumptions, choose equations, calculations, check solution, and discuss results. In your engineering notebook, please answer the following questions. How does the design process guide the engineer from a loosely understood problem to a highly defined solution? What is a design brief and what information does it contain? Why do engineers conduct research? What is the difference between primary and secondary research? What is the purpose of an engineer's notebook and what kinds of information are typically recorded in it? What is the difference between a prototype and a model? Give an example of a kind of test that might be performed on a prototype. Why are there guidelines for brainstorming? And identify 2 advantages that CAD systems have over traditional methods for producing technical drawings by hand.